Good afternoon. Good afternoon. It is such a pleasure to be here and to welcome all of you. My name is Karen Abraham. I'm the Dean here at the Faculty of Medical and Health Sciences at Tel Aviv University. And we are here to inaugurate the Sieratzki Institute for Advances in Neuroscience. What can I say? This is an emotional moment. We've been working for quite some time to bring this all together. And Dr. Sieratzki, what can I say? From the bottom of my heart, we are just thrilled. I think that the audience here shows what a strong neuroscience community we have here at Tel Aviv University. And we represent all the excellence and the good in Israel. I can't continue without acknowledging the very difficult and challenging period that we're under. And Dr. Sieratzki has been such a special and good friend during this time. I know calls that we've had, Zooms that we've had when the crises started, and the support and the care and the emotion that you've shown for us has just really been so heartwarming. But through it all, one thing that really brings us all together is knowing that we need to be strong and we need to move forward, taking everything that's happening with us. So in that light, we have the opening of the Sieratzki Institute for Advances in Neuroscience. And I think this is really a place to celebrate our science, how much we're working towards bettering health and disease, that we're all working together to strive forward so that we'll have a future not only for ourselves, but for our children, for our grandchildren, and for the really outstanding students that are here at Tel Aviv University. Because in fact, and I know, Dr. Sieratzki, you'll agree with me, this is what much of the Institute is about. I want to also acknowledge Professor Sieratzki, who's going to be the head of this new institute, and thank you very much for taking yet another responsibility on you. And to all of you who are part, those of you who have been awarded the Sieratzki Prize in Neuroscience, it's such a pleasure to see you. There's a whole alumni group here. And Dr. Sieratzki, you had foresight because I know that you handpicked, along with your committee, all of the winners, and they have turned out to be the creme de la creme of neuroscience in Israel, and not only Israel, in the world. And we will hear from one of them today. So I would like to introduce our president, Professor Ariel Porat, to say a few words. Thank you.
Thank you very much, Karen. Dear friends, Harry, faculty from the Faculty of I need to get used to the new name. You know, it's the Faculty of Medical and Health Sciences. Indeed, these are very difficult times for Israel, and you know that Harry visited here several times since October 7. I remember that we have met at my office. I think it was after October 7. Now, you know, time's confused, and I think that especially these days it's so important to support not only like immediate emergencies, and which is of course also very important, but to understand how important is the academia, and Tel Aviv University is part of the Israeli academia. This is about the future of Israel, and so thank you very much for being so generous to us. Let me say a few words about the new institute, about the project, and then a few words about you, Ari, and your beloved mother. So the Sieratzki Institute will work on 3 levels. First, it will award excellence fellowships to master's, doctoral, and MD, PhD students, as well as postdoc students and researchers in brain science fields. Second, it will acquire state-of-the-art scientific equipment for the collective use of affiliated researchers from across the campus, including a miniature microscope. And third, it will relaunch the Sieratzki Prize for Advances in Neuroscience. On the 32 previous prize recipients, many have become leaders in their fields. Members of the Institute will include former winners of the Sieratzki Prize, as well as other esteemed scientists, including Professor Nir Giladi, incumbent of the Sieratzki Chair in Neurology, Professor Talma Handler, Professor Ilana Gozes, and Professor Aviva Fatal-Velevsky. The institute will be led by a committee headed by the chair of the Tau Department of Physiology and Pharmacology at the Faculty of Medical and Health Sciences. The committee will include 4 former winners of the Sieratzki Prize alongside the donor himself, Dr. Harry Sieratzki. The committee will be responsible for selecting grant and fellowship recipients. Let me say a few words about Harry. Harry lives in London, but originally comes from Frankfurt. He is a medical doctor in both internal medicine and pediatrics, with a special interest in pediatric neurology, and held senior positions in Bristol University, Imperial College London, and University College London. Harry continues a 30-year family tradition of supporting neuroscience at Tel Aviv University, really long time ago, a field in which he has considerable understanding and expertise. He is in personal contact with all the winners of the Sieratzki Prize, not easy, 32 people, and follows their career. Just as he was always involved with the prize, so too he is now involved with the institute, the call for fellows, etc. Harry decided to hold the inauguration this year, despite his sister Luba Zelcher not being able to attend, in order to show full solidarity with Israel during this difficult time, which is really so important for us Israelis. He has visited Israel a few times since October 7, as I've already mentioned, and this is highly appreciated. Thank you, Ari, for your solidarity with Israel, with Tel Aviv University, even more important, with Israel. Let me say now a few words about Harry's beloved mother, the late Barbara Sieratzki. Barbara was born in Krakow, Poland, in 1927. She is a Holocaust survivor, and for a while, that's a very interesting point in her CV, right? She was in prison in Budapest with Hannah Senesh. Between 1945 to 1947, Barbara studied in the University of Budapest, philosophy, arts, history, and languages. From 1949 to 1976, she lived with her husband, Heinrich Yecheskel, and their children in Frankfurt. They had a real estate business. Barbara and Harry thought it is important to support Israel and young researchers, understanding that this is, in fact, the future of Israel. That's what's important for the Jewish state. They donated in 1995 the Heinrich Yecheskel Sieratzki Chair in Neurology at Tel Aviv University, as well as in 2009, the Sieratzki Prize for Advances in Neuroscience, which is now revitalized and incorporated into the new institute. In 2016, Tau celebrated Barbara's 90th birthday at the then annual awarding ceremony of the Sieratzki Prize. She was a much loved member of the Board of Governors of Tel Aviv University and was passionate in supporting young, talented scientists. May her memory be blessed. So thank you so much for supporting the university in such an important field and for continuing a tradition that has been started together with your beloved mother. We really appreciate it very much. Thank you. You are a great friend. Yeah, where is it? Yes, it's here. I'm sorry, forgot. You know, this is the first ceremony I participate in this Board of Governors, so I'm still not used to the, but that there should be a certificate, but here it is.
But you're doing very well.
Thank you. I'll do my best. So let me read it for you all, and then we'll take a photo with the certificate. So this is to witness that on the 27th day of May, 2024, Tel Aviv University inaugurated the Sieratzki Institute for Advances in Neuroscience in memory of Barbara Batia and Heinrich Yecheskel Sieratzki Zal. In the presence of Dr. Ari Sieratzki, thereby creating an outstanding framework for rewarding excellence among talented young medical researchers at the graduate, MD, PhD, and postdoctoral levels, upgrading the scientific equipment available to biomedical researchers from units across the campus, relaunching the esteemed Sieratzki Prize for Advances in Neuroscience, further reinforcing the legacy of the Sieratzki family in supporting neuroscience at Tel Aviv University over many years, and providing a worthy means to perpetuate the memory of the late Barbara and Heinrich Sieratzki among new generations of Israeli students and researchers. Let's stand here.
Dr. Sieratzki, Harry, don't go. Oh. Okay, good, okay. So before I introduce our guest of honor, I'm actually going to acknowledge Professor Roni Gamzo, who's the head of the Tel Aviv Sieratzki Medical Center, Ichilov. Thank you so much for joining. We're really honored. So now it's your turn, Harry.
Thank you.
And we already heard about your mother, and I'll just add my personal note that I remember several Board of Governors when I had the honor of knowing Barbara Batia Sieratzki, and that was when I met you as well. You were always together. You were such a devoted son, and it's really wonderful that you're continuing this in her memory. So now we're going to hear about remembering my parents and looking forward.
Dear Ariel, dear Karen, thank you very much. Friends present here and joining us by Zoom, I appreciate the honor of you participating at this event, especially honoring my mother, who was a strong supporter of Tel Aviv University for almost 40 years, an engaged governor and an honorary fellow of the university. She established the chair of neurology in the name of my late father in 1995, as Ariel already referred to, and in 2009 we jointly founded the Sieratzki Prize for Advances in Neuroscience, which made us enormously proud. The reason why I'm standing here in front of you today is because of her. It's an enormous pleasure and privilege to work with the young scientists of Tel Aviv University. At this time of tragedy and uncertainty, it is their enthusiasm and friendship which gives me hope and strength. 3,000 years ago, David HaMelech wrote, Gam kilech beget salmavet lo irara ki ata imadi. Though I walk through the valley of the shadow of death, I will fear no evil, for you are with me. This sentence is as true today as it was 3,000 years ago, and ever since when our ancestors were persecuted. My parents were survivors, and so were the parents of my friends here from Frankfurt, whom I've known since childhood. It's my pleasure to see you. I also welcome with great pleasure my friends from the neuroscience community, from all over Israel, former winners of our prize for advances in neuroscience, the best of the best, who still remember my beloved mother. And I welcome my new friends, whom I met after my mother's passing, and I'm grateful to all of you who provided invaluable help in organizing this event. Toda. It is the second time in my life that I have the honor to speak at Tel Aviv University. The first was 29 years ago when I spoke about the life of my father, Sieratzki. I have today the honor to speak about the life of my mother, Barbara Batya. Batya was born on 28 March 1926 in Krakow. Her father was from Opatów, seat of the famous Abda Yeshiva. He had smicha and was an elegant, charming man. His biggest pleasure was to study Gemara on Shabbat afternoon and smoke a cigar. The one cigar per week he could afford. My mother's mother was a quiet and pious lady who loved Yiddishkeit. She was the first woman in her family not to put on a sheitel and to have a proper office job in Krakow, and worked hard to have her two daughters have an excellent education. Barbara and her older sister Ida went to the Chaim Hilfstein High School, where she learned Hebrew, which she spoke fluently throughout her life. When her parents could not pay the school fees, Barbara, at age 11, earned money by tutoring, and the school waived the difference. Her memories of pre-war Krakow were happy. A large family and fun. There was no sense of the upcoming catastrophe which would destroy this world. At the onset of the war, Barbara and Ida were staying with their grandmother, while their parents were in Prague trying to pick up some business. Her father sent a messenger to Krakow to bring the girls to Prague. In the evening before their departure, Ida told Barbara that she had to go and see a friend. She was not back in the morning. She had joined her friend to go to Lemberg, where she got arrested and sent to a coal mine in northern Russia. Somehow, Ida managed to survive and became an officer in the Red Army. In the meantime, Barbara was smuggled out of Krakow in the coal tender of a train. She arrived in Prague without her sister. Her father had visas to Portugal, but would not leave Ida behind. The family stayed in Prague. Barbara went to school and learned 3 new languages: Czech, English, and French. There was still a sense of relative safety. After 2 years in autumn 1941, the family was warned not to go home. Their names were on a list of Jews to be deported. They walked out of Prague, and after a period of 2 months, crossed the Hungarian border. The father managed to procure Polish Christian IDs, and the family settled in Budapest. You're still looking at the picture of my mother 3 years old, because there are no pictures of the time in between. Barbara attended a Polish Catholic school and picked up another language, Hungarian, which she spoke passionately, really, throughout her life. In 1944, the political situation in Hungary changed, and the family tried to escape to Romania. They were arrested in Szeged. This was the last time that Barbara saw her father. He was deported to Auschwitz, survived the camp and the death march to Dachau, but succumbed to typhus in March 1945. Barbara and her mother were taken to the Gestapo prison in Budapest and then to Mauthausen, Oberlanzendorf in Austria, where they had to work as weavers. Her mother could not manage to stand all day at a weaving frame, so Barbara worked both frames. A Dutch couple known for her brutality forbade this, but Barbara succeeded to persuade the work supervisor, and so her mother could survive. The camp was liberated by the Red Army. A Jewish officer helped them back to Budapest. How does one do that? To Budapest. In June 1945, Barbara was accepted to Peter Pasmani University. Her student card shows a very pretty young woman. She earned money as a translator and by smuggling between Bratislava and Budapest. One day in Bratislava, her mother said to her, "Do you see this Russian soldier over there? If my Ida were still alive, that is what she would look like. It was Ida. They procured civilian clothes and papers for Ida and moved west to the British occupied zone to Bergen-Belsen. Barbara became a connection officer between the Jewish camp leadership and the British Army in the rank of lieutenant. In 1949, my father, born in Piotrków, a survivor of the camp Częstochowa, together with former Chief Rabbi Lau, heard of Barbara. He had settled in Wiesbaden in the American zone and decided to travel up north to Bergen-Belsen to look her up. Like in a fairy tale, he had the key to the princess's heart, Barbara's mother. He treated her in the way he would have treated his own mother had she not been shot to death in 1942. When he visited Barbara, he brought flowers hidden in his briefcase and did not go to see his future bride in the public swimming pool. This was his tradition, that's how he was. The chuppah, that's the ketubah from Bergen-Belsen. The chuppah took place in Lohheide near Bergen-Belsen in the house that had belonged to a top Nazi and was now kashered. They then moved to Frankfurt, and Barbara worked with my father in his textile import business. The biggest client, people from Frankfurt will know what it means, was Neckermann. A few years and businesses later, they went into property development, and in 1960 built a large commercial building in the center of Frankfurt. So that's a chuppah. And these are the early post-war pictures in Germany. So my parents on the right. I think that's some distant cousin. There was a custom in Germany for the new year to have a chimney sweeper for luck. And that is probably from the early 1950s, mid-1950s, which was really an amazing period in Germany, you know, where people looked forward and lived. Nobody wanted to look back. This is probably from the 1960s in Frankfurt. It's probably also from the 1960s, my father and my mother there. And that's my father very happy in the middle with my mother here and my sister Luba over there. That's my mother with my sister, probably 1968, I would think. And that's a picture, it's a picture with my mother and her mother. They survived together in, as I had said before. And that's probably a picture from the 1970s. A few years and businesses later, they went into property development, and in 1960 built a large commercial building in the center of Frankfurt, which was led to a well-known department store and allowed the family to live in comfort. In 1971, Barbara's mother died, and her sadness was great. During the course of the 1970s, the department store, which had expanded in the wrong time, declared bankruptcy. A new tenant was found, the Central Library of the city of Frankfurt. At the openings, the mayor said, "A house of books for the people of Frankfurt in a house of the people of the book." Just before this event, my father died of a stroke. It was 1976. Barbara was only 50 years old. She had been with my father for 27 years and would go on living with him for another 42 years. Not for one moment would she accept the role of a widow who is pitied and then forgotten. She kept our business alive and began to travel on a Greyhound bus across California, diving in Mexico, visiting China and Egypt as early as 1979. Barbara moved to England in 1982. I come to that. when Luba, my sister, got married. I recall how we traveled to Strasbourg to buy kosher meat at Buchingers for the wedding, and how at the airport I chatted up a few Hasidim to take a few of our suitcases full of meat. Sometime after the wedding, Barbara was introduced to Bernard Sandler, a widower and divorcee from an unhappy second marriage. Bernard and Barbara had 14 good years together, traveling the world, going to theater, concerts, art exhibition, and arguing about politics. Bernard was a happy socialist and sadly died in 1998 when Barbara was 72 years old. So here, that is a picture, I think, when my mom visited me in New York when I was working there. I think it was actually on a Seder, on Pesach. No, it wasn't. It was at Rosh Hashanah. Not sure whether the picture was taken on Yom Tov. That's my mom now with two of her grandchildren, my sister's children here, Simone on the left and Lizzie on the right. That's my mom, Luba, and the third grandchild, Henry. They're all a little bit bigger now. And that's how she enjoyed herself. That's a picture from the 1995 inauguration of the chair. And as I said before, there on the left side is my friend, Professor Dienstein, who sadly passed 3 months ago. Otherwise, I would have been honored to see him here. And on the other side is Professor Eckstein, who was the president of Bar-Ilan University at the time. And I said before to Ariel Porat, the president, it's a unique situation that you have the presidents of 2 universities present. And here is my mom at that inauguration together with Amos Korchin, the incumbent, who was sitting, I think, at the moment in an aeroplane to fly to California to a bar mitzvah of his granddaughter. And here is my mom receiving her honorary document as a fellow of the university. And this is here the first prize in 2009. On the left, Roy Cohen-Kadosh and Yaniv Asaf, who is where? Somewhere here. Oh, disappeared. This is at the time also the inauguration in 2009. In the middle, Yechiel Ben Tzvi, unforgettable friend, and Professor Galil, Tzvi Galil, who Tzvi on the Zoom. And with the rector at the time, Professor Leviathan. And here with Yechiel Ben Tzvi and Mr. Adams, who created the Adams Super Center for Brain Science. And they had a nice exchange. I see my mother and Mr. Adams at that moment. And a couple of years later, again, with Amos Korchin. And here with Sami Sogol, I don't see him, didn't come. And then Barbara remained full of energy. She was a strong supporter of Tel Aviv University for many years and made personal friends from presidents all the way to young students. Still today, 6 years after her passing, people tell me of how they remember her with affection and respect. She was a courageous, determined woman, and our own relationship grew stronger as she got older and frailer. I look back and I know that I never in my life knew a person who loved more to live, and I would have loved her to live more. I think this picture is from 2014 at home. Here, I think perhaps 2 years later, 2015, 16, sitting on her balcony overlooking Hyde Park. Here we went on a little tour inside Hyde Park and found an ice cream dealer, which she obviously delighted in. And here, still older, still full of energy and full of life. And I think this is from 2016, with students actually from Hebrew University, where we supported the teacher training program for students for teachers of Jewish studies, Dikla, Shira, and Metal. So these are, I'm now coming to the winners of our prize of the last, since 2009. As I said, Roy Cohen-Kadosh and Yaniv Asaf, 2009. This picture is not very sharp. It's the only one that I have. In the middle is Alon Chen, who's now the president of Weizmann. Next to Alon Chen is Eran Persson, who's somewhere here. Next to Eran is Bumi Zangen. Bumi Zangen here, head of neuroscience at Ben Gurion University. Next to, between Alon Chen and me, is Amir Mehdi, who's not here today, who is traveling, I don't know where. Who is now, who's a, also very, very capable person. Now, this is here, next year, Yossi Yovel, don't see him, who still is currently the president of the Sagol School for Neuroscience. My friend and powerhouse, and loving powerhouse, Ina, Ofer Yitzra from Weizmann, and Nachum Olanovsky also couldn't come. He's a Batman. They're studying bats. They're both studying bats, which is incredibly interesting stuff, but it's not my time to speak about it. And here's a lovely picture of two lovely and somewhat powerful young ladies. Now that's the next year. There is Shira Nafo here, and Ilana Gozes, still one of her best friends. She couldn't come today, she's in Haifa. Yitzhak Michalewski, he didn't come. Adrian, where are you? There. Adrian and Nia. Here we are. He didn't win the prize. That was the year when he took over the chair from Amos. Next year is Ilan Dienstein, who's from Ben Gurion, who's now the head of the Institute for Autism in Ben Gurion, but he's on sabbatical in America. Where are you? I saw you before. Pablo also disappeared. Professor McCory, the former dean of the medical school, and Yuval. I know you're here. You cannot disappear. You have to speak. Inbal Goshen from Hebrew University. She's in Berlin at the moment. Professor Gottel, there you are, also with Ilana. And here there was a visitor, Carla Schatz, who was a very from Berkeley, I think, and my mother. And that's a student of yours, I think, Ina, right? That was a PhD student of yours. And then next year, Michael Yartsev, who was also a Batman, a very, very successful guy. He went to Princeton and now in Berkeley, and I'm still in contact with him. And so we have to work to get him back. Segev Barak here, and Yaniv Ziv, who's at Weizmann. And Segev, where are you? Here at the end. So who is also a member of our committee now. And this is too many people to name. But there is, of course, Nia on the side, and Ilana, and Uri Asheri here. And I'm still in the middle with longer hair. And if you notice, please, with the same suit. Just a different tie. And this is the last time we met here. And I get signs that I should move on. Thank you very much.
thinking whole movie is your connection to mother. No, really. I have a mother now, a 97-year-old, and I understand what does it mean to have affection and connection to your parents. But what you've illustrated here now is demonstrated. This is something that everyone would like to have such a real and strong connection to his parents. He's a good guy, by the way. We walk together back.
After half an hour.
רגע, please just... And without me? I got it, and one without. Professor Johnson? Harry? Last one, please.
So, I'd like to introduce my friend Paul Heller. Paul is I want to introduce my friend Paul Heller and my friend Or Amadeus Stormy. Paul is a Chazan of the Belsize Square Synagogue in London. It's actually a German liberal synagogue. I'm by myself a little bit more traditional Orthodox, but for some reasons, my mother liked the shul very much because we could sit together there when she got older, so we went there. And he was a very good friend to my mother, Paul, I must say. And a year after my mom passed, I made a concert in London, and Paul sang at a concert together with other people beautifully, and he will sing the song that is sung there, Mizmor LeDavid, of which I quoted before one of the central sentences.
Thank you, Harry.
And here's my friend Odromi, and I think his parents are here. Yeah, here they are. He's the sweetest guy.
Thank you, Harry. I just want to say how honored I am here to mention one thing, which is from Ecclesiastes Rabbah, the Midrash says, a good name is better than fine oil. The day of one's death is better than the day of their birth. In other words, we have no idea how someone's life will be spent, whether or not they will contribute greatly to society or disappear without a lasting name. So to our sages, the idea of celebrating the day of one's birth is seen as a counterintuitive, but someone has left an indelible mark on history, then surely it is fitting to celebrate the fullness of their life. From the day they were born until the final breath. As we remember the day before yesterday in Lag BaOmer, Rabbi Shimon Bar Yochai, who wasn't just a great rabbi, but who gave us so much joy, light, wisdom in the world, and his teachings, the way we celebrate him with singing words of Torah. Today, as we also remember our beloved and righteous Barbara Sieratzki, I will honor her, as Harry said, by singing Psalm 23. I'm very honored to have also Or playing. Mizmor LeDavid, Adonai rohi lo ezar, binat Hashem yarbitzeni, al mei menuchot yehaleni. nishanta b'shemen roshi, nishanta b'shemen roshi, osirevaya. Ach tov v'hesed yirdefunni kol yemei tayai בבית אדוני לאורך ימים.
Thank you so much, Cantor, Heller, and Ordromi. Very much appreciated. It was beautiful, very heartwarming. Okay, so now we're going to hear from Professor Nir Giladi, who is the incumbent of the Sieratzki Chair of Neurology, and he's going to tell us Remembering Barbara. Thank you.
Okay, so this is a great honor to share with you my personal experience with the Sieratzki family. I actually took over the incumbents of the Sieratzki chair after Professor Amos Korchin, who was holding this chair from 1995 to 2012. He was my mentor and my teacher, and I followed him since 2012 and had the privilege of knowing Barbara in person and also getting to know Harry as a real friend. This is the picture that is in my office where both Barbara and Yechezkel are in Bergen-Belsen, two Holocaust survivors, and look at the look and the smile. This is who looks at me every morning, and one cannot ignore the hope that comes from those two faces after all what they have gone through. So this is a real privilege every morning to see them looking at me and me looking them, especially in the current period in Israel. Both are, by the way, buried in Jerusalem. And Barbara, as Harriet already said, was a real global businesswoman, amazing in her business abilities, but also with a special passion for science and education. And what we see here in Tel Aviv University is just a marker of her interest. We have heard about the prestigious prize that Harry initiated and all the winners, that some of them are here with us. And I think this was a real, very interesting process where Harry always was extremely involved in all the details of choosing the best people. And I think what those people have reached in their career just to show us how precise this process was and how right you were in knowing every person's exact publication, reading most of the articles, and really being on top of everything. And Barbara, I have had the privilege of knowing her personally, spending time with her in dinners, in different places, as well as in her home. Was a real unbelievable woman with great laugh, endless energy, and always with new ideas, and a real woman of people. Even at the later stage of her life, she was so soft, so passionate, and so want to know everything and want to share everything. And it was a real wonderful evenings that we had together, either at their home or in different restaurants, or even went once to visit her in the hotel here in Israel, and I remember all those memories very well. But as Professor Porat said, Harry has, throughout the years, is keeping the memory of his parents, but I think you have shown that you are taking this one step further, and you are really leading as a man of vision and great supporter of neuroscience. I think that you have been involved in so many different projects, and the institute that is now established here in Tel Aviv is just showing how your passion and love to your parents is now taking to its next stage. And I think all of us just can thank you, and me personally, for all those years together. And I think this is a picture, also a special, very moving picture with Rebbe Lau, and remembering how everything started after the Holocaust. This is the next generation. So thank you very much, Ari, for all what you've done.
Thank you, Professor Giladi. And it's now my real pleasure and honor to invite Professor Sieratzki, who's going to tell us about the role and impact of the Sieratzki Prize and the Institute for Advances in Neuroscience. And before she starts, I do want to say, as everybody knows, Ina is a powerhouse of science in her own right. I think hardly a month goes by where there's another fabulous paper, PR piece, and your talent from being able to convey the message of what you're discovering so that the public who really need to learn about it is really remarkable. You've been a leader at every level. I know your students would certainly attest to the same. And it's within this spirit that Ina has decided to take upon herself to head this institute, really for the next generation. So thank you very much, Ina.
Dear Harry, esteemed guests, faculty members, and dear students, I am proud and honored to be leading the Sieratzki Institute for Advances in Neuroscience. This would not be happened without so generous donation of Dr. Harry Sieratzki, given in memory of his parents, Barbara and Yehezkel Sieratzki. I extend my heartfelt gratitude to Harry for his unwavering support, particularly during these challenging times, both for Israel and its academic community. My appreciation also goes to Professor Ariel Porat and Professor Karen Avram for their invaluable support in establishing the Institute. And a special acknowledgement to esteemed members of Scientific Committee of the Institute, Professor Yaniv Asaf from Faculty of Life Sciences, Professor Yuval Nir from Faculty of Medicine and Health Sciences, and Professor Segev Barak, the head of Psychological Sciences School. All of them are recipients of Sieratzki Prize in Neuroscience. And many other recipients are also here in the audience. Following the best part of Jewish tradition, midor ledor, or from generation to generation, many students of Sieratzki Prize recipients have already established their own laboratories and already mentor their own students here in Israel. We anticipate that several more who were honored with the last student prize at Barbara's 90th birthday will return to Israel and will be an integral part of our scientific community. We are incredibly proud of them, and we are fortunate that Sieratzki family chose to support the neuroscience community of Tel Aviv University as a cornerstone of Israeli neuroscience. As a president of Israel Society for Neuroscience, I am deeply grateful to the Sieratzki family for their decades of support for the neuroscience community in Israel. The Sieratzki Institute will support a wide spectrum of disciplines, including neurogenetics, neurodevelopment, cellular and molecular neurobiology, biophysics, neural circuit dynamics, system neuroscience, cognitive neuroscience, computational neuroscience, and neuroscience of human disorders. Our philosophy is to foster the development of strong quantitative, analytic, and creative skills to ensure that the next generation of neuroscientists we produced here are equipped to embark on a wide range of scientific careers. Our laboratories are highly interactive and collaborative, and it's common for advanced made in one laboratory to stimulate new findings in another laboratory. I would like to thank my exceptional colleagues across the campus, many of them are here, who inspire me daily. You are smart, compassionate, and share a belief that the creation of new knowledge is one of the most important of human endeavors. Our graduate students are the heart of our institute. There is a joy in watching them develop as mature and independent scientists. I love watching my students searching for an answer to deep philosophical questions such as what does understanding mean, and listening to their arguments. I love teaching introduction to neuroscience course because it starts from very basic principles in cellular neuroscience and moves to explore how cellular mechanisms contribute to higher level processes. I enjoy watching light in students' eyes as they understand a new concept. Sometimes when I walk to the rig rooms and watch recordings of neuronal activity by my students, I find myself in the same state of wonder that I first felt as a beginner graduate student. Peeking into mysteries of life never gets old. We are privileged to see the success of our ex-students in academia and industry. When we think back, we can point to numerous contributions of our trainees that took us in new directions and pointed us to fundamental insights we would never have discovered without their creativity, technical skills, and intelligence. I would like to cite Richard Feynman. What I cannot create, I do not understand. The mission of Sieratzki Institute is ambitious, yes, yet essential, to nurture the scientific leaders of tomorrow who one day will be able to reverse engineer the brain in order to understand the mind. To this end, we offer Sieratzki Scholarship of Excellence for PhD students at Tel Aviv University who will delve deeply into the mechanisms of the brain at any level of investigations. We will invest in cutting-edge infrastructure and recognize emerging talents, the early career scientists who are establishing their labs across the country. And finally, to the young members of our neuroscience community, I commend your scientific achievements and encourage you to continue delving deeper into our understanding of the brain. May your endeavors lead to groundbreaking discovery that may help us one day to predict and treat neurological and psychiatric disorders. Thank you. And finally, we are moving to the very exciting and scientific part of this event. And I would like to introduce ex-Sieratzki Prize winner, Professor Yuval Nir. And very briefly, just I would like to mention that Yuval graduated PhD at Weizmann Institute in the laboratory of Professor Rafael Malach, and then he moved to postdoctoral training to the laboratory of Professor Giulio Tononi in Center for Sleep and Consciousness. And I would like just to say that Yuval and his team members, some of them are here, made really seminal contributions in understanding how sleep affects information processing in the brain and cognitive functions. For this, Yuval has been awarded by many prestigious awards, including Sieratzki Prize, including Adelis Prize, and many others. And Yuval, the stage is yours, and we will hear today about frontiers in sleep research. Thank you so much.
All right, here it comes. So thank you, everyone. I know it's getting kind of late. First of all, I'd like to thank Harry for your generosity and your friendship and your vision. Thank you, Ina, for initiating and making a dream come true with this institute, and Keren Avram for your support, Nir Giladi, Talma Handler, and everyone here. So I'd like to share with you some new frontiers in the neuroscience of sleep. And I'll do so, and I promise to wrap up at 2 o'clock. So here we go. I think it's fair to say that throughout most of history, we've treated sleep as a waste of time, as a state of nothingness. This artifact is from 5,000 years before the birth of Christ. It shows Sarpedon, son of Zeus, king of Troy, as he's carried back from the battlefield by these two winged characters, Hypnos and Thanatos, the twin brothers of sleep and death. So this is how we've traditionally thought about sleep, as a state of death, a state of nothingness. And when you think about it, it still goes quite deep. This is how we use our language. We may take our dog to the vet to put it to sleep, or we may board an airplane and put this in sleep mode. So it just shows that deep inside, a lot of us think that sleep is the state where nothing happens. It's like death. But of course, we now know that this is far from truth. In the last few years, in the last 20 years, there's been so much research that we now appreciate that sleep is essential for health, for our brain health, for maintaining the connections between nerve cells in our brain synapses, for immunity, for mood. And in a way, we're now in the other extreme. We have all these, we have all this awareness, we have all these gadgets, we have apps that tracks our sleep, and they tell us exactly about how well we slept tonight, and we have these fancy rings, and we put our smartphone into a mode that we won't have too much blue light before we go to sleep, and we've become very aware. In fact, one of the main reasons why people have difficulties falling asleep today is what's called sleep anxiety. You know, they've read on Ynet that if they have bad sleep, they're going to become, they're on their way to dementia, and it's already been 20 minutes, and I haven't fallen asleep, and this is bad for me. So we have become hyper-aware, and I think this is the good side of things to be in, and now we appreciate sleep a lot. If we zoom out and we think about sleep and health, for many years, this is the image that comes to mind. Sleep and health, mostly around breathing disorders, people who may suffer from sleep apnea, and they're given these instruments, the CPAP instruments that sort of take us back to the early 90s, Saddam Hussein, you know. It's very, a lot of sleep and health, or sleep of medicine, has been about breathing. But in the last few years, there's been a remarkable transformation where the worlds of neuroscience and brain research and the world of sleep are coming together. And I think it's a very exciting time. And we now understand that sleep is a fantastic window into brain health. So if you think about it, almost anything that can go wrong with our brain, be it in psychiatry, schizophrenia, depression, anxiety disorders, or in neurology, anything from autism through epilepsy, Parkinson, Alzheimer, all these conditions manifest as something different from the normal during sleep. If we watch our brain during sleep and we listen carefully, we can identify a lot of things that go wrong. And here's one example. This is about 10 seconds of the EEG during sleep, recorded from two individuals 70 years old. And you can see here, these are what we call slow waves of sleep. And they're actually quite large in this person, but you can see that they look different in this person, right? The amplitude is lower, the frequency is higher, just looks different. And it turns out that this individual is an Alzheimer patient, as can be confirmed with imaging. So if we look at brain activity during sleep, we can recognize and identify a lot of things about brain health. And usually when we look at sleep, we use what's called polysomnography, a combination of different signals that include the EEG, and also these sensors around the eye orbits to measure eye movements, and these sensors to measure muscle tone. And we can identify what we've been calling now for 60, 70 years sleep stages. So if we look at activity of the EEG here in this case, you can see it's quite different when a person is awake. This is about 15 seconds of activity. The activity is very fast and low amplitude. But as people fall asleep, it immediately changes. In what we call stage 1 of sleep, you can already see it's a bit different. The amplitude is larger, it's a bit slower. This is a very short stage of sleep. By the way, if you wake up people from this stage, they mostly say, I wasn't asleep. They wake up with this very strange guilt or denial about their sleep. And after a few minutes, people proceed to what we call stage 2 of sleep, and we start seeing these slow waves appear here and there, and also this other event that's called a sleep spindle. It's a very characteristic oscillation that happens with waves that occur 10 to 15 times per second. And after about half an hour, they'll enter what we call the deepest sleep, slow wave sleep, or stage 3 of sleep. And look at the EEG here. Look how different this is compared to when a person is awake. After about an hour of sleep, they'll enter what we call rapid eye movement sleep, where their brain is active again, much like when they're awake, but their body is completely paralyzed apart from the muscles that control the eyes and the diaphragm to allow continuous breathing. This is, of course, the stage of sleep where if we wake up people at the lab, they'll readily report vivid dreams and so on. So this has been very useful for science and also for sleep clinicians, for sleep medicine. You know, if someone says that someone has been in stage 2 sleep, whether they've done this study in Brazil or in Tokyo or in Minneapolis or in Rehovot, we're talking about the same thing because it has rules, it's standardized, and that's been very helpful. But it's also a very limited approach. We're not going to understand the brain by working in these stages because this assumes that the entire brain is doing the same thing, and also that the same thing is happening for 30 seconds at a time. This is just not how the brain works. It's much more complex. And I'd like to show you a few examples of how, when we appreciate the complexity of how the brain works in space, in time, and across different frequencies of electrical activity, then we can make sleep science something much more exciting. So I believe the future of sleep is to go beyond sleep stages, to understand, to monitor, and to intervene with high resolution in space, time, and frequency. And let me show you some examples. So the first is what I call spatial resolution, or to go beyond global sleep, beyond treating the entire brain as the same thing. So in the early 90s, it was discovered that at the level of individual cells, individual neurons, when we measure these slow waves here in a sleep lab, what happens inside our brain are that neurons alternate between these active periods that we call upstates, and they have this firing, and these silent periods when the neurons are hyperpolarized or silent. So neurons are active and silent, active and silent. And it was believed that nearly all the neurons in the brain go up and down together synchronously at the same time. But there were also examples to show that something more is happening. For example, in some marine mammals, for example, in dolphins, dolphins, of course, are not fish, they're mammals, so in order to breathe, they need to continue to swim to the surface to grasp for air, just like us. So they've evolved this very strange and unique pattern of sleep, where one hemisphere shows these slow waves, it's asleep essentially, and the other half or hemisphere of the brain is awake, and it controls continued swimming, and the other side, the eye of the other side of the body is open. And after a while, the two halves of the brain switch, and the part that was awake is now asleep, and the part that it was asleep is awake. So there were signs that sometimes sleep is not the same thing across the entire brain. And we set out to study this about 15 years ago in collaboration with Itzhak Fried, a neurosurgeon at UCLA, and until recently at Ichilov, who treats epilepsy patients who don't respond well to the available drugs. So these patients sometimes are implanted with depth electrodes to monitor where do the seizures begin from in the brain, and is it a localized region that can be potentially treated by resection of the pathological tissue. So this is actually a CT after implantation of these electrodes. And it provides a very unique opportunity to look what is going on inside the brain during sleep. We can also record electrical fields across many different brain regions, in addition to the standard sensors that determine the stage of sleep. And when we started looking at these signals, we saw that it was not like what was written in the textbook. It was a bit more like the dolphin. We saw that we could see these slow waves occurring in one region, and the neurons became silent, but at the same time, another region was active, and a few seconds later, this region became silent, and the other one was active. And this was true not only in epilepsy patients, but we've also replicated it in rodents in the lab, in this case, in the rat. So most of the time, different brain regions go on and off at different times, not necessarily in sync. And the interesting thing, it happens not only when animals are asleep, but also when, in this case, rats are awake. If you keep them awake 4 hours past their normal bedtime, then these sleep waves will start invading the activity of the awake brain. While they're standing, their eyes are open, they're trying to perform a task, these sleep waves will start invading into their brain activity and actually affect their performance. And this is work by Vlad Vyazovsky, who's now at Oxford. A few years later, we've shown also that when these sleep waves invade the activity of humans after a night of sleep deprivation, then this is associated with lapses, with those moments when you're presented with an image and you have this lapse of attention and you don't really respond behaviorally. This is precisely when these sleep waves invade the activity of the brain. And we hope that by this understanding of sleep waves happening at different regions, we can also develop and improve monitors of sleepiness. And with time, as a community, we can develop monitors that can tell us if an individual has been sleep deprived or sleepy. For example, before they go driving a truck, or before they go, ranging from cardiac surgeons to flight control workers. Now we don't have an instrument like the Yanshuf for measuring alcohol intoxication, for measuring how sleep deprived a person is. That would be very important. More fundamentally, at the scientific level, we are beginning to think that we should treat different brain regions, each being in its own state. So one can be more in a sleep state, one can be more in an awake state, and this depends both on the intrinsic features of that region, the cell types, the receptors, also its history, and also each region, we believe, receives a slightly different cocktail of what we call neuromodulators, or the brain hormones, if you will, that we thought are secreted like a global spritz all over the brain at the same level, but we now realized it's much more complex, it's much more like a circuit, and each region receives a slightly different cocktail. The second theme is about complexity and time. So we'd like to move beyond static sleep and look at how things change from moment to moment during sleep, both abnormal activity and also in the healthy brain. So a few years ago in the lab of Sieratzki, Rafaela Atzmon and Daniel Zarchin led a study where they've shown that in transgenic mouse models for a genetic form of Alzheimer's disease, so these are mice that try to mimic a severe form of Alzheimer's. If you look at their activity of healthy mice, it looks like this when they're awake and like this when they're anesthetized. Very stereotypical pattern of activity that we call burst suppression. But if you look at different mice that are serving as models for Alzheimer, the activity is pretty similar when they're awake. It's when they are anesthetized or during natural sleep that the differences become very notable. And these differences include what we call these spikes, these very sharp events that you find with a level of a few times per minute in the disease model mice, but almost never in the healthy mice. This happens deep in the brain, in and around the region we call the hippocampus. And it was also shown, this study by the Harvard group, showing that in a few super rare cases when Alzheimer patients were implanted with electrodes in the hippocampus, around the hippocampus, you could also see this abnormal interictal spike, what we call an abnormal spike, and these occur mainly during sleep. So we thought, wow, could we develop something that would enable to also detect these type of events non-invasively in people? Work by Rotem Falach, who's here, I think, and together with Firas Fahum, who heads the epilepsy at Ichilov Medical Center, we've used machine learning, we've used artificial intelligence, and in rare cases where we had data both from inside the brain and from non-invasive sensors, to train the machines to pick out signatures in the non-invasive data of what happens deep in the brain. And now we can achieve much more than what we can see with our own eye. So our machine tells us, okay, here actually happened a spike deep in the hippocampus. It's not necessarily something you could see with your eye, but indeed, in many cases, the machine is correct. And when it says, it misses some events, but when it says that an event had occurred, then it has quite high precision. So we can finally have a tool to non-invasively detect these abnormal events that occur, of course, in epilepsy, but also possibly in Alzheimer and in many other conditions ranging from traumatic brain injury through ADHD to autism. So we're very excited by this. Another thing that changes all the time is our level of arousal. So, you know, the ancient Greek philosopher says you can't walk into the same river twice, right? Everything changes all the time. And also the depth of sleep changes all the time. First of all, it changes between individuals, right? Some people sleep through anything and others wake up from anything. And also for the same person, if I'm stressed or if I have a flight tomorrow, I'm gonna sleep differently than usual, right? And also during the same night, I'm gonna have changes in how deeply I sleep. And we were interested what is really driving these differences. In a study led by Chana Chayat, together with Noah Regev and Noah Matosevich, who are here, we suspected that a certain chemical called noradrenaline may play a specifically important role in this. And what we've done is we've established a way to control these cells in the brain that secrete noradrenaline with a method that's called optogenetics. So by shining blue light through an optic fiber, we can make these neurons do what we tell them to do. And actually, since the noradrenergic system is tightly correlated with the pupil, as soon as we turn these neurons on, we see that the pupil dilates. And what we found is that this really modulates the chance that we will wake up from a sound. For example, if we give a slight backwind to noradrenaline, we will wake up many times from a sound. But if we silence the noradrenaline system, the same sound will not wake us up with the same probability. So we think it's very interesting, and we'd love to develop ways to also measure noradrenaline changes in regular human sleep, as we've done in the rodents, and we're working on that under the hood for many years, and I hope to share with you some exciting developments. There's a teaser and a hint here for those who follow the details. All right, how about interventions? It's important we listen to the brain with complexity, different regions, that we track brain activity with complexity in time, different moments. How about intervening? So one study led by Maya Geva-Sagiv, again, collaboration with Yitzhak Fried, we wanted to actually change and manipulate activity during sleep and see if that could affect memory. And we knew many years from animal research, we suspected that interaction between two brain regions, the hippocampus and the cortex, may be especially important for that. So we wanted a way to manipulate that, and Maya developed closed loop stimulation. What we did is we listened to activity in the hippocampus during sleep, and when we noted that it was in a certain active mode, we delivered intracranial electric pulses in the frontal lobe, in the front side of the brain, very mild pulses, all safe, with a neurologist present in the room, and the patients volunteered for this, and all good. And when the hippocampus was active, we sort of gave a little push to the front of the brain to be in a more receptive mode, to be listening to the hippocampus. And it turns out that this type of stimulation during sleep improves memory. People wake up with better memory than a normal night of sleep. And also it does so by improving the synchronization between regions around the hippocampus and regions in the front of the brain. There are different brain waves, like slow waves, spindles, and ripples that become more correlated. The more we affected the electrical activity, the more we were able to improve the memory. We're also seeking other creative ways to manipulate specific brain activities during sleep. For example, Elabar, a joint student at the Weizmann Institute, developed a way to present smells to one nostril during sleep, thereby affecting memories that are stored in one half of the brain. And also Omer Sharon, when he was at the lab, helped test a system for non-invasive vagal nerve stimulation. There's one branch of the vagal nerve, it's called the auricular branch, that ends at a certain point close to the left ear. And if you stimulate that point on the ear, a bit like acupuncture, then you can reach that nerve and affect some arousal systems in the brain. So the final 3-4 slides, and then I'm going to wrap up, is something about specific frequencies. I told you about specific areas in the brain, told you about specific times in sleep. What about frequencies? One question that we've been very interested in over the years is what we call, is there anybody in there? You know, is a sleeping person aware of what's happening around them? To what extent does the brain process external information? Like this cute baby sleeping here. You know, does he really hear what's coming out of this speaker? What's going on in their brain? And we've been studying this both in humans when we've delivered different sounds when they're awake or asleep or anesthetized, and also in many animal experiments with different students and different colleagues at the medical center. And I'd like just to end by showing you one example, and where we played this famous Mozart piece to a patient at Ichilov who was implanted with electrodes in their auditory parts of the brain, in the centers that process sound. So we've all heard this, right? And appropriately it's called Eine kleine Nachtmusik, little night music. And we've played this, and I'd like to end by showing you this is activity of one individual neuron, nerve cell, in a person, in a human, on the 4th floor of the Sami Ofer building at Ichilov. And this is how this neuron responds during about 6, 7, 8 hours of sleep, with the patient volunteered to have speakers by their bed. And if we listen to the activity of this neuron, it sounds like this. So by listening to the neuron, we can find evidence that the brain in this region is really tracking the sound that is entering the ear, and using such tools we can understand to what extent does the sleeping brain analyze the sound, and when do things break up and change during sleep when we're unconscious of our external environment. And we believe what we've seen is that although individual neurons fire quite similarly, when we look at specific frequencies of the electrical fields, we find something different. We find that the high frequency activities, these red columns that we call gamma activity, faster than 50 times per second, are quite similar when a person is awake or asleep. But the lower activity in what we call alpha and beta frequencies, when a person is awake and aware of the sound, then this activity is reduced in power, it's shut down. But during sleep, actually, this shutting down process is very much different. And we know from many other studies that the shutting down of these frequencies reflects some feedback activity from higher regions in the brain. So what we think is happening is both when we're awake or asleep, the sound goes from the ear to the brainstem to the thalamus and up, 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 that's fine. But when we're asleep, it's this second wave of feedback that is really influenced by the state of sleep, and it's something that we're now trying to understand better in animal models. And we think that such understanding can help also deal with other unconscious conditions when we're not sure to what extent an individual is aware of their surroundings. For example, in surgical anesthesia, or in disorders of consciousness, in coma, in vegetative states. So my take-home message is that to take sleep to the next level, we need to really marry it properly with neuroscience and its complexity. If I want to understand some electrical device like this one, I'm not just going to like see what's going on in a level of 30 seconds. And I'm not going to intervene by going like that. We need precision. We need to dive into the spatial resolution at the millisecond level. And when we do this for an electrical device, like the brain, that's the brain's language, then we can really take sleep to the next level. For those of you who want to follow more activity of our lab here, and I usually end my lectures with a fabulous picture of my team and my funding sources. But today,
Yuval, Professor Nir, that was really remarkable. Well, I want to thank all of you. This has just been such a moving, such a touching ceremony. I didn't acknowledge, and I want to, Dr. Bensi Wall, for being here as well. And all of you, it's just been really, I think, no words, and I look forward to discussing afterwards. We will not be able to do the question session now, but I am inviting you, before we have Hatikva, back to where you had the refreshments. There's coffee and cake. And then Professor Nir, Yuval, I hope you'll be there and you can answer as many questions as possible. It is a fascinating topic because we all sleep, we all need sleep, and we are so intrigued by the intricacies, and you described it so beautifully. So Cantor, Heller, and Or, I want to invite you to Hatikva. I want to thank all of you. Be safe, be well, and again, Professor Harry Sieratzki, Dr. Harry Sieratzki, thank you for everything. Just before you go in for the food, all of the winners that are here, please, we want to do a group picture before you leave. Okay, thank you.